So whenever you have a equation with two radicals, you want to make sure they're on opposite sides of the equal sign. So we'll start out and we get the square root of x plus 2 is equal to 1 plus the square root of 2x minus 3. All right, so we're adding the square root of 2x minus 3 to both sides. Now, once I have the radicals on opposite sides, then I'm going to square it. Okay? And this is another situation where if you know the perfect square trinomials, okay, squaring them to where you get a squared plus 2ab plus b squared, it makes things much easier for you. The left side here is going to be x plus 2. All right. The right side is much more difficult because it means you have to multiply these together. Because it would be wrong. Okay. All right. For the same reason that this is not equal to this. Okay? If that was a true statement, then yeah, you could just get rid of the radical and you'd be all happy-go-lucky. Okay? But it doesn't work that way. So this is going to be 1 plus okay? All I did is use the fact that the perfect square trinomials, a plus b, that quantity squared, is a squared plus 2 times a times b plus b squared. Okay? So 2 times a times b is going to give me 1 times this is just 2x minus 3. And if you're going to have 2 of them, then you just put the 2 in the front. Okay? Now, the only thing that happens here then is what we need to do is we need to move everything but the radical to the other side. Okay? And then we're going to have to square it again. Okay? So with these problems, you end up having to do square it twice. Okay, you ready for this? All right. Square root of 2x minus 3. Square root of 2x minus 3 gives me 2 of them. Okay? Okay. So we have x plus 2 equals, and I'm going to simplify this side first. So we get 2x minus 2 plus 2 square roots of 2x minus 3. Now I don't want to, all these on the right hand side are multiples of 2, but I don't want to divide by 2 because I don't want to work with a fraction right now, okay? I want to avoid that if I can. So I want to get the 2x and the minus 2 on the right hand side, or on the left hand side, because I want the radical, I want to isolate that radical again. So we're going to subtract 2x and add 2. Uh-huh. Yep. Right. Now, I'm still not going to divide by 2 here, okay? Because I don't want 1/2 over here. Okay? So I'm going to square both sides now. So when we do that, okay, so we have x squared minus 8x plus 16 equals, what's the right side going to be? Okay, it's going to be 4 times 2x minus 3, exactly. So 8x minus 12, but I didn't want to jump to there quite so quickly. Okay, so we get x squared. Yep, these take a while to do. Only 15 of them. Okay? Do you think I'd make you do 15 of those? No. I'm not that mean. All the time. Okay, so we have a quadratic equation. We want to get it equal to 0 so that we can hopefully factor it. So we get x squared minus 16x plus 28 equals 0. So this is x minus 2 and x minus 14. So x equals 2 or 14. Okay. So we need to check it. Yep, the answer is right there. So here's the thing. If I put 2 in here, okay, so we're trying to get positive 1, right? So if I put 2 in for x, which we've got it right here, 2 plus 2 is 4, so the square root of that is 2. 2 times 2 is 4 minus 3 is 1, okay? So 2 minus 1 equals 1. Oops, wait a minute. Oh yeah, yep. So 2 works, all right? Put 14 in, we get 16, which is 4, minus the square root of, let's see, 2 times 14 is 28 minus 3 is 25, so that's 5. And 2 minus 5 is a negative number, and we needed positive 1, so 14 doesn't work. So my answer is just x equals 2. That was a special problem.
Can we look at the recording thing and see how long that took?
Only 7 minutes, 8 minutes for one problem. That's not bad. Not bad. Okay. There's not 15 problems. Right. Right. At least. Okay. The thought process takes them at least that, or double. Okay. All right. Hold on. All right. Oops, where we at here? Okay. Number 6. Oh, I don't know, but the in the engineering programs and like that, the amount of calculus and like that you're going to be doing, you will be doing some problems that take up full pages and plus. So, well, except the way you write. Okay. All right. Okay. Or you can just not do them. So, okay. All right. An industrial engineer is designing a conveyor belt system for a factory. An item will move a distance of d meters along the belt from a point P to point Q, and then drop onto another belt and move x meters from Q to R. He needs to position Q so that an item will get from P to R in 4 minutes and 24 seconds. The belt from P to Q will move at a rate of 4 meters per minute, and the belt from Q to R will move at a rate of 10 meters per minute. Find the required distance x from Q to R. Okay. Okay. Now, first of all, we have here a right triangle. Okay. If the distance from Q to R is x, then the distance from Q to the edge of the right triangle is what? 20 minus x, okay? All right, so this distance here is 20 minus x. So then, we have a right triangle. What's the one thing that we use with right triangles quite often? Okay, the Pythagorean theorem. So we can use the Pythagorean theorem then to find d as a function of x, okay? Because d squared is equal to 8 squared plus 20 minus x squared. So d is equal to the square root of that. All right, so let's start there. Okay, so we know the two distances we're trying to cover. Okay, one distance is square root of 64 plus 20 minus x squared. Okay, the other distance is x. Okay, and we know that they want our total time to be 4 minutes and 24 seconds. Okay, so the total time that it takes to go from t1 plus t2 is equal to 4 minutes and 24 seconds. All right. So let's get a decimal number. What is 4 minutes or how much of an hour or a minute is 24 seconds? No, that's not 4.2 minutes. No. 24 seconds is how much of a minute? 0.4. It's 24 over 60, right? Okay, what is 24 over 60 reduced to? 0.4, right? Because Sam's right. It's 2/5. Okay. So our total time here, we want to be equal to 4.4 minutes. Okay? So what I need to do is I need to find out the time from P to Q and the time from Q to R. Well, we know the speed, don't we? Okay. We know that to get from P to Q, so to get D, D is equal to 4 meters per minute times, we'll call that time 1. Okay? You all right with that? Okay. And x then is equal to 10 meters per minute times time 2. All right? It goes down the hill slower than it goes on flat ground. Does that make sense, Gibby? I guess it could. Probably because if it's going downhill, they don't want it to roll off if it goes too fast, right? So they got to go a little slower. Okay? All right? Definitely not. All right? Okay, now, D is equal to this, isn't it? Okay? So T1, time 1, is equal to square root of 64 plus 20 minus x squared divided by 4. Okay? Because distance, D, is equal to that radical, and so the time is equal to the distance divided by the speed. Okay? Distance divided by speed, right? Okay? And then T2 is equal to x over 10. All right, So we have, don't you love distance, rate times time problems? So then these two things added together have to equal 4.4. Good. Okay, so how am I going to solve that then? Multiply by what? Now you're going to go here, okay? After all the brain power you just used, well, maybe you used. Now you want to plug it in your calculator because you really don't want to go there with, okay? Yep. So you want to either solve it somewhere with your calculator.
Can you make a calculator where you can just like take a picture of the problem and figure it out?
Yeah, I wish. You know, I was yesterday, you know Cameron. So it's, what's that? Move the calculator. Yep. Okay. Now, was there another answer?
Yeah, find the distance.
Well, x is the distance. Put x in for x.
You gotta find P and Q, right?
They're asking for the required distance from Q to R, which is what we just found. Okay, 8.05 meters. Okay, let's check the other number because it's well, it's not obvious, but it looks like it might cross somewhere else, right? So let me change but here's the thing though, okay? All right. Look at my window right now on my calculator. My x max is 20. And the largest my answer would be 20 because the distance from this right triangle to R is 20 meters. So if x was larger than 20 meters, that's impossible in this situation. So I don't need to look at anything bigger than that because doesn't make sense for the situation. Okay. All right. Fun stuff, huh? That's a very difficult question. I will. Okay. Only 10 of those. All right. 15 of the others and 10 of those. So far we're on, so 15 plus 10, shoot, it's only going to take you 6 hours to do the homework. All right. No big deal. All right. Solving, we got last one here, okay? That's not the one on yours? No, because that's one out of the book. Here's the one on yours. Okay, so let's just do the one on yours. So what do I need to do if I have a rational equation and it's equal to 0? What do I need to be concerned with? Okay, what? Like terms or how about a different word than terms? Factors. Okay, all right. So if I have a common factor, that means I have a whole, right? Okay, so that can't be a solution. But the only time this is going to be equal to 0 is when the numerator is equal to 0, because when the denominator is equal to 0, we have vertical asymptotes. Okay, so if we want to factor it, and then we're looking for common factors. Anytime there's a common factor, then that negates the 0, because it would be a whole in that situation. So let's see. All right, so let's think through what I was saying for factoring. Right? We want the factors of -6 that add up to 1. Okay, so 3 and 2. So that means then that if this is 2x, then the 3's got to be here. Okay? Because if the 3's over here, I'm going to end up with 6. Right? Because That gives me 6 when I multiply them together. Okay, and I don't want 6. I want to do 3 minus 2. Okay. So we have 2x plus 3. The 3's got to be positive, and x minus 1 in the numerator. In the denominator, I'm going to do slide and divide with you for this one, okay? For the numerator, just because I want to show you something with that, and that will help your life in the future. Okay. The denominator can that be factored? It can.
No.
Okay. All right. Okay. All right. Because the factors of 6 that add up to 5, 2 and 3. Okay. All right. Oh. Oh. Okay. All right. So, since I have a common factor here, these cancel. And then my answer in this case is just going to be that x equals 1, where the numerator is equal to 0. And we would have a hole at -3 in our graph. But we don't care about the hole. We just need to know the fact that that doesn't work. Now, one of the things I want to go back through slide and divide for you just for a minute, for those of you who, is that what is, at 2x plus 3, what's a 0 there? Okay, it's 3 over 2, right? 0 is going to be -3/2. Okay. So if I do the slide divide method, which says that we're going to get x squared plus x minus 6, right? I multiplied a times c. Okay. So then I factor it, and we get x plus 3 and x minus 2, correct? Okay. So this is the factor. Now, I'm going to divide the coefficients by a. Okay. So we've got, or divide the constants by a. So I'm going to divide this by 2 and this by 2, and then I'm going to simplify. So this is going to be x plus 3/2 times x minus 1. Now, the reason I wanted to show you this is the fact that if I'm trying to solve an equation, okay, then I'm done. Okay, I don't need to go any farther, because this tells me that the 0 for x plus 3/2 is -3/2, because it's the opposite, right? And the x here is positive 1. Okay, so the reason that the slide and divide thing, I like it, for those of you who have, if you haven't seen it, is because when I get to the simplified part, it tells me the zeros right away. Okay, they're there. To where then, if I need to actually factor it, then yeah, then I need to bring the 2 back over here, and I end up with 2x plus 3, oops, and x minus 1. Okay, so, but if you're just trying to find zeros, then I'm done here. I don't need to do the last step. Okay. So just a reminder.